Taking the Heat is the name of this article, really. Now, you guys, we talked the other day about heat, about exchanging heat. We're going to loosely define, what's the first law of thermodynamics? Who can tell me what the first law of thermodynamics is? You got any idea? You ever heard of that? The first law of thermodynamics? You have to, in order to get energy, you've got to trade matter for it. You have to burn wood to get heat. You know, it's the way it used to be, you know. We burn gasoline that makes the heat, that pushes the piston that drives the car down the road. Okay, that's the first law of thermodynamics. You can't create matter or energy, but you can actually trade one for the other. You got that? All right. Now, if I got an alternator or generator or something, I'm going to, and it can actually have fields of magnetic induction. I'm going to have to put energy into that device in order to get energy out of it. That makes sense? Okay. Now, and every time you do this, you're going to lose something. Now, the gasoline that we burn to make the heat, our cars are only like 20% efficient. You know, the power that you're getting out of the gas when you're going down the road, there's not a whole lot. There's a bunch of it that's going out as heat, basically. And so what they're trying to do, you know, with this hybrid vehicle stuff and all that, is come up with a more efficient way to burn fuel and all that. But incidentally, they said on Fox News the other day that General Motors, I think, is going to quit building the Volt, and they're re-outfitting that plant to build Impalas. Which I kind of thought the Volt was a cool car myself, because it had a little 3-gallon gas tank, and it wasn't that the engine didn't charge the battery. The battery was charged when you plug it in, and also when you stop the car, it would charge the battery. But the engine was there in case the battery went dead and you still needed to go somewhere. You put 3 gallons of gas in it and go. That's a pretty smooth idea, I thought. I mean, I wasn't against the Chevy Volt, but there were some problems with cooling the battery's liquid cooled and all that. But anyway, so the second law of thermodynamics is what? What's the second law? Second law of thermodynamics, if you heat something up, it's going to cool off. Isn't it? If I take a piece of steel and I heat it with a torch, I've used energy to heat this piece of steel. I've used, oxygen and acetylene or whatever to heat the piece of steel. The piece of steel gets red hot. Is it going to stay red hot? No, it's not. Heat flows to cooler places. Now, there's going to come a time, and I don't know when it's going to be, a long time off, if the Lord tarries, when there's going to be heat death. And what does that mean? No more work can be done.
Negative 263?
Huh?
Negative 263?
Well, I mean, yeah, I guess everywhere. I mean, everything is just going to be totally, there's going to be no heat anywhere to do anything with, right? And so basically, and another way you could say, that's like the law of increasing entropy. I can take a Crown Victoria or a Chevy Impala or a Lamborghini or any kind of car you want to talk about, and I park that dadgum thing out here in the field somewhere, or maybe even in a building, an air-conditioned building, in a controlled environment. If I leave it there long enough, I'm going to go back and find flat tires, froze up brakes, a car that won't start, a dead battery. See what I'm saying? The law of increasing entropy says, and how many of you have ever seen you move out of a house, you come back to it, it's falling apart? I mean, an empty house, a lot of times it starts falling apart. I don't know if you've ever experienced that before, but I have. I owned a house in Port Arthur, Texas, and I left for 3 months. Then some up here and started working, and I went back down there to sell it. And when I walked in it, it was just coming all to pieces. You know, and I mean, yeah, it was an older house, but it never did that while I was living there. And it wasn't because I was always nailing the trim back on it or nothing. His stuff just started popping loose and coming apart, you know. Anyway, that's what the law of increasing entropy is about. And things don't get better by themselves. If they get better, somebody's got to make them better. Got that? Anyway, that's the second law of thermodynamics. So, when heat transfer takes place, something's always lost. Got that? Everybody get that? When gasoline is oxidized, what we call it burning, is it burns, it expands, it applies force and heat to the environment, which would be your top of your piston. And in a controlled environment of a combustion chamber, the force is harnessed and applied in such a way that it can be used to do work. It's just the way it is. Okay, but the conversion of gasoline to power isn't 100% efficient. So you got to get rid of the heat. You got to convey it out of there, or it's going to burn something up. Heat exchangers don't always protect machinery, though. Which heat exchanger would be what? Give me an example of a heat exchanger.
Air conditioner.
Well, sort of. An air conditioner consists of 2 heat exchangers and a compressor. What's a heat exchanger? Would be a radiator, a heater core, or anything like that, right? So All right. Sometimes their purpose, like a heat exchanger, doesn't just protect machinery, like in the AC, like you were talking about. You got an evaporator and a condenser. Now, what does a condenser do? What happens in the condenser, Sean?
Condenses fluid.
Yeah, you got compressed. You got high pressure gas coming from the compressor through the discharge line to the condenser. It turns into liquid. As it turns into liquid, what's it doing? It's giving up heat.
Yeah.
There's a fan pulling air across that condenser, or when you're going down the road, it's pulling across it. Okay. After it becomes liquid, it goes through a liquid line, and it goes past an orifice, a fixed orifice, or a expansion valve, and then it goes into the evaporator as a low pressure liquid, and as it's going through the evaporator, it's turning into a low pressure gas, and as it's doing that, what's happening? It's absorbing heat. So that's what makes your evaporator cold. That's what makes you nice and comfortable in the summertime, right? What else does it do? It dries out the air. Okay, so anyway, the AC heat exchangers act as a heat pump. They capture heat from in that car, and they send it out here, and they get rid of it outside. The heat pump that we're here and run right now, the evaporator in here has got the refrigerant's evaporating in that evaporator, and the compressor is sending it up there onto the roof to that condenser unit, and it's actually getting rid of the heat. It's just pumping heat out of the house, you know, and so we've always got cool stuff in here. So to prevent heat damage on liquid-cooled engines, coolant's pumped through the engine block and the cylinder heads to maintain the integrity of these expensive components, because it takes a lot to build them, right? And the convection is the process there. You actually absorb the heat as the coolant comes in contact with the cylinder head and the block. And write this word down, convection. You got conduction. The heat is conducted from the metal parts of the engine into the coolant, and it is conveyed away from the metal parts of the engine by the flow of the coolant out to the radiator. All right, so the radiator, actually, they call it a radiator. You know, years ago in buildings, they used to have a radiator. They'd have hot, you know, water going through it. This thing in the corner over there, and it would give off heat and heat the building and all that kind of stuff, but you had to have boilers in the bottom of the building to do that. Okay, so spark plugs give up a lot of heat too. Did you know that? Spark plugs give up heat, and if you don't have your spark plugs good and tight so that gasket is squished or that little bevel seats against the head, then the spark plug can overheat. Just burn that sucker up. Look like you put a torch on it. Matter of fact, I had one here that this boy cross-threaded a spark plug, and it went down in, and it stopped about with that washer dangling with about a quarter of an inch of space, and you know, the car seemed to be running okay when she left, and she come back a couple of days later with it skipping, and we pull that plug out. It brought the threads out of the head with it, and the head. I got that spark plug here somewhere, and it just absolutely cooked that spark plug on the tip. It looked like you held a torch to it and just melted the end off of it.
If it overheated real bad, could it cause pre-ignition?
Mm-hmm. That's like a glow plug in there, lighting the mix off before it's supposed to. All right, so heat travels to colder matter by default. Okay, now you know them little small ports the head gaskets has got in them? If the head's got a big old port that the coolant flows through, but right there at the gasket, they choke it down to a little bitty port about a quarter of an inch in diameter. And it has to slow that coolant down so it can absorb the heat that's going through the head. If you ever, we got some gaskets one time, and I mentioned this, I think, in a lecture last semester. There's a guy named Shannon Smith that was here, that was from Elba, and he actually, when he pulled the head gaskets out of the package, we're getting ready to put head gaskets on a 3.8 liter Ford Taurus, I guess it was, and when he looked at them, the head gaskets that came off the car had these little bitty holes where the coolant goes through, you know, out there on the edge of the gasket. You can see it in that diagram over there. And the new gaskets had accidentally been cut with the holes the same size as what was in the head. I've never seen that before, but he caught it. He held them up and he said, "This doesn't look right." I was really impressed with that, because if you put them head gaskets on there without looking at them, and now the car's overheating, you're going to be scratching your head for a while. What did I do wrong? You didn't do anything wrong. The gaskets were cut wrong. Well, he caught it, and I called Sam, and Sam called Felpro, and Felpro says, "Oh, crap. Send those gaskets back. Don't ever use those." Oh, my word. They were just like, oh, you know, because this would have been burned up somebody's motor, and it would have been on them, because the gaskets were cut the way they were, see? So they sent us some that were cut right. Okay, so heat travels to colder matter by default. That's another note. So the circulating fluid we call antifreeze, or we call it coolant too, absorbs and then carries the heat away from the protected components to pass through the radiator, and it's mounted so it relieves a high volume of airflow at road speed. And since the air is cooler than the radiator, the heat picked up by the engine keeps on moving. It goes to the cool air. Okay, between the radiator and the engine, there's a shroud. Now, let me just tell you something I'm probably going to forget to tell you if I don't tell you. when you look down at the top of a radiator shroud on a car that's got a belt-driven fan, I'm talking about the ones that the older pickups and all got a belt-driven fan. You're gonna see this radiator shroud right there like that. And I don't have a good marker there, but I've got a belt-driven fan. And the fan, you got your pulley right here that's driving the fan, right there, whatever kind of pulley it may be. That fan, you need to be seeing half of those fan blades sticking out. If you don't, if you ever put a thicker radiator on there or modify it some kind of way, so that that fan is submerged up in that shroud where the fan blades are up in here, instead of being half exposed, that vehicle will overheat. Now that's something nobody, you can talk to 100 mechanics and they wouldn't know it. I mean, if you tell them that, they just absolutely wouldn't know it. And you could actually put some shims some kind of a way behind the radiator that was so that they couldn't see it, and bring that in so that those fan blades were not exposed. In other words, you know what I'm saying, you're seeing half of the fan blades when you look down on it from above, and it would overheat that vehicle. I've seen that, I've been there, I've fought with that. You know, when this guy put this radiator on his Ranger that was bigger, he had put a bigger radiator on it, it was thicker, and that fan was up in the shroud. And we worked on that son of a gun for a long time trying to get it overheat. And then the shop foreman came and he says, you know, we had some trouble with some vans that they built wrong, that fan was totally submerged in that shroud. And he said, because of the fact that we had them fans totally submerged in the shroud, those things were overheating. All right, it's got them platinum plugs there. Were they in it? Were these wetter ones? I mean, you got some that are really wet.
No, not really. They're all about like that.
All right. Now, did you start it up before you pulled them out? Fire it up and let it run. You know, put the plug wires back on it good enough for it to run. Fire it up and let it run for like, 30 seconds or something, or maybe a minute, whenever you know that it's. And of course, it's probably gonna be skipping and whatnot. Switch it off, and then jerk them back out and let's see which ones are wet. I ain't saying get the car hot, but I want to know which ones are wet because we got injectors dripping.
How's the fire?
Huh?
How's the fire?
Yeah, that's handy. But anyway, what I did was I took the radiator shroud off and I marked it with a piece of masking tape, and I got a high-speed cutter and I cut that shroud so that I exposed half of them fans, and that took care of that problem. Cool.
It's not getting any air. It's not.
I don't know. I cannot explain the dynamics, but it seems to me like it'd be like a wind tunnel pulling air better if the fan wasn't submerged. I mean, it seems to me like it'd work better that way, don't it, to you? But it doesn't. I mean, I guess it's got to spread the air out or something, or some kind of way it's trapping the air in there, and it doesn't, and it winds up not getting good airflow through there.
Is the fan blowing new air to the engine, or is it pulling old air?
It's pulling it through the radiator. Now, I will tell you this: if you ever see one that's overheating driving down the road, but it won't overheat when it's sitting still, and with that electric fan running, like if it's got an electric fan, put a piece of newspaper in front. If it in front of the radiator, if it blows it away, you know they've wired the fan up backwards. Because a lot of these electric fans come with pigtails sticking off of them, and you're supposed to wire up the fan, and you better wire it up so it's pulling air through instead of blowing the other way. Okay, you got that? All right, now then, but the engine that pushed those buggy-looking cars Henry Ford built was designed to percolate water out of the block through the cylinder head up a pipe into the radiator, so that the air passing through the radiator would absorb the engine heat and lower the temperature of the water for it and went back to the block. Let's see, right here, you might even notice that on some of those old flathead engines that Henry Ford built, they had the cylinder head was a flathead, and they had a water outlet sort of a thing. It started way back here, and it came up there, and then that hose went into the top of the radiator. And as this engine was creating this heat, it was like a coffee pot. The radiator was over here, and then it fed back in here like this. And as it percolated, it pushed water up here, and it would keep coming down here, and you get cold water coming in at the bottom. There was no water pump on those old cars. They didn't have any water pump. Furthermore, there's another little sidebar here. The gas tank was right in front of the windshield. The carburetor's here that gravity fed into the carburetor. And if you drove, that's why the gas cap was right in front of the windshield, that round silver thing. That was the gas cap. And if you headed up a hill, so that the hill was steep enough and your gas was a little bit low in your tank, it would run out of gas up the hill and you just coast back down. And the only way you get up the hill, turn around and back the car up the hill. See? I mean, you had to be able to troubleshoot that stuff. Okay. So, but anyway, we don't often consider the these little water pumps, the little efficient water pumps that pumps the fuel, you know, and pumps the water rather. And it's amazing when we factor in the hostile environment. Now, this is my axiom that I'm always using all the time, and I've never heard anybody else say these exact words. I always put it in these magazine articles I write, so there may be other people saying it now. The component, I told you this yesterday, the component that is in the most hostile environment is the one that usually fails. The one that's working the hardest, and that's the water pump. It's not at all unusual for water pumps to go out, because they are really working hard. Now, what are things that contribute to water pump failure? What's the way the water pump can fail?
Corrosion of the metal surfaces that can.
That's part of it. What else? What about flakes of rust in the cooling system getting in there and acting like little razor blades and cutting the seal? You know, and it starts leaking because it's cut up with rusty stuff in there. If you got a radiator cap, it's just letting air come and go. It's going to cause rust in that cooling system really bad. Because that oxidation is going to be able, and you'll see a little bit like that. You also see electrolysis in cooling systems. And sometimes if you got really bad electrolysis in a cooling system, you may be able to take and go from ground on the engine block and dip your positive lead on your voltmeter into the water in the radiator. You may read 4 volts because of the acidity or the alkalinity of the water or whatever. And it's basically, you know.
How does it wind up with electrolysis occurring, though? I mean, how does it get to the point where it becomes that acidic?
It gets where it's more and more acid, I guess. I know that they make, you know what an anode is on a boat? Any of you guys ever fool with aluminum boats that work in salt water? If you look on an aluminum boat, on the back of it, you'll usually see a couple of things that are mounted like this, and they look like it looks like a gray piece of lead almost. And they're mounted, they're insulated from the boat, but they're mounted on the back of the boat, but they're not mounted, you know, they're not touching the boat. And there'll be usually 2 of them, and they'll be laid in there like this, you know, one that way and one that way. And that electrolysis of that seawater eats this anode away, and because it's eating the anode away, it's not attacking the aluminum. If you build an aluminum boat and you go out in the ocean with it without anodes on it, it'll dissolve. It won't happen right away, but it starts eating the aluminum away. You'll see the pits starting to grow in that aluminum. After a while, it'll start leaking everywhere. So they have to put anodes on the boat to make that quit happening. Now, you can buy radiator caps. You can go online and look for them. I can probably pull it up right now. You can buy radiator caps with a little anode on the underside of them so the electrolysis in the cooling system is eating the anode away. Now, this is not a very common problem. If somebody keeps their coolant replaced, you know, and they got a good tight cooling system, it's not letting air come and go, you don't typically have a problem with that. You see what I'm saying? So, but that's just something, you know, word for the wise. Some of this stuff is stuff I'll forget to tell you if I don't tell you. And I'm trying to share as much knowledge with you as I can. So don't feel like you shall surely die. All right. So coal running engines, though, aren't fuel efficient. So you need to keep the engine good and warm. So the engine needs to run about 200 degrees in order to, make sure you write that down. A cold running engine is not efficient. It's inefficient enough emission-wise to where the engine controller is programmed to let you know if the thermostat's not working. In other words, you'll see these codes here. You'll see a PO 128 or a PO 125. PO 128 means it's running a little bit too cool, and the PO 125 means it's running really cold.
I think cause them to run rich.
Yeah, it'll make them run rich, and it'll also have more, because of the fact it's run richer, you'll have blow-by. It's going to thin the oil, because gasoline is going to get mixed in there with the oil, and you'll have some of that anyway. You know, whenever that blow-by goes, if some of the gas doesn't burn, if it's in places where the fire can't get to it, like in there between the top of the piston and the ring, you know, and all that, and that winds up getting in there. And if somebody goes a long time without changing their oil, the oil starts smelling like gas. And so, all right, so here we go. Air-cooled engines have got fins cast on the outside surfaces of high heat components, cylinder head. You know, lawnmowers, you know what I'm talking about? They got air shroud going over it, it blows air through there. So they give you a lot of surface area for the air to blow across that keeps them cool.
Like fluted barrels.
Huh?
It's like fluted barrels.
Yeah, well, sort of like that. You got a bunch of, you know, fins on the outside of them. On the jugs, which is like the cylinders on a Volkswagen Beetle, they had fins on those, and there were fins on the cylinder heads, and they had these shrouds and this big strong fan to blow air down through there. There's one guy that worked at a Volkswagen place down in Texas, said that he was the man that owned this Volkswagen Bug brought a car making noise. And, you know, there's a fan, you know, below the window, below the back window on these Volkswagen Bugs, the old Volkswagen Bugs, you got a sort of a bunch of louvers right here. That's where the air comes from that gets pulled in there into the front of that engine, and then it blows it down across those cylinder heads and all that through a shroud. There's an oil cooler in there too. There's a heat exchanger. So a lot of the cooling that takes place on a Volkswagen Bug is oil. There's somebody said is a radiator for a Volkswagen Bug. You know, back they used to laugh about that, but actually it does have a radiator. It's got a heat exchanger in that shroud because there's oil gets pumped in there and it gets cooled off. And a lot of it's cooling. But the long and short of it is, this guy said, "Got a noise my Bug is making." So the guy could tell it was something behind it that was caught up in that fan. And when he reached up in there, he was pulling out wads of $100 bills. And that guy said, "Wait, that's my money." Well, see, he was going to be smart and hide his money in there behind some of these felt panels in the engine compartment. And the felt panel, since he pulled it back kind of loose, and it started pulling them $100 bills out and pulling them into his fan. I mean, that was plumb comical. You don't hide your money in your engine compartment because you could have a fire under there and burn it up, you know. All right, so here we go. Let's see. Let me get past some of this air-cooled stuff I'm talking about. Okay, now then, on turbocharged engines, the air jammer, which is going to be your turbo. What's the difference between a turbocharger and supercharger? Somebody tell me.
Superchargers work all the time. A little bit of horsepower is sacrificed so that the supercharger can be belt driven. Turbochargers generally only, because they work at certain RPMs.
They spin all the time, pretty much, but they're going to work the hardest when you're really into it. See, they actually got exhaust spinning one side of you know, the turbine, and then on each side of this shaft, you got a little thing that looks like a jet engine, right? The turbine and an impeller, and it spins. The exhaust actually spins I don't want to get this backwards. The impeller is what is spun by the exhaust, and on the other end of that shaft there's a turbine that grabs the air and shoves it into the engine. It's naturally aspirated.
It would seem to me like a supercharger's power would be kind of balanced all around, whereas it seems to me like a turbocharger, it's more high-end stuff. Sort
of, but like on the newer diesels, they got variable geometry turbochargers, so they get like a little turbocharger whenever it needs it, and then it acts like a big turbocharger when it needs more power. But anyway, if you're compressing this air, what happens when you compress air? It gets hot, and it also condenses, but it gets hot. And so, what's the problem with hot air when it comes to burning it in an engine?
There's less air getting in.
There's less oxygen in a cubic inch of hot air than there is in a cubic inch of cold air. So if you supercharge an engine without an intercooler, you're just really not getting near as much benefit. Like at Park Avenue Ultra that lady drives that comes in here, gets the oil change, got a big supercharger on it. It's got no intercooler. All right, now how many of you opened the hood up on a Thunderbird Turbo Coupe? You ever seen those? I'm not a Turbo Coupe, a Super Coupe, I'm sorry, with supercharger on it. Turbo Coupe's turbocharged Super Coupe, they came out in '89, it's got a supercharger on it. You look at the top of the engine, it's got this big, beautiful supercharger on it. And you might think if you look at that supercharger, that there goes in the top of that supercharger and on down into the engine, right? That's what the old 671 blower did. You know the thing that was sticking up out of the hood with this thing? That actually pushes air right down to the engine. Well, it ain't got no intercooler on it. An intercooler is actually a radiator that cools the air that's been already compressed by the supercharger. So, in order to put an intercooler on this Thunderbird Super Coupe, they let the air come in through the breather. It goes in through the bottom of that supercharger. It comes out the top of it, goes around through the intercooler, and then it comes back into the engine. Isn't that crazy? It goes in the bottom, comes out the top. The air is actually flowing up, around, and then finally making it back to the engine. It's got high pressure air going in there, and it's cold. And since it's been cooled, it's a lot more dense, and your car's got just a lot more power.
If you cool the air off, though, how does it remain compressed?
Well, actually, it can be compressed and cold. You know what I mean? I mean, you know that. I mean, you're not going to have it if you cool it off. It's contracting a little bit, but you still got pressure. You got more than atmospheric pressure. That's the point. All right. So Fluids that are moved under pressure by a positive displacement pump, like the power steering pump, got to be cool too. Did you ever think about that? You ever seen the power steering cooler on a car? Sometimes you'll see little tubes running underneath there. It'll be some little odd little cooler that's kind of by itself, where this tube runs back and forth, and you don't know where it went, and it'll have fins on it.
Yeah, it's like a small transmission.
Like a little tiny thing, yeah. And that's for power steering. Sometimes they just run the power steering fluid a long way. They don't necessarily put fins on it. They just run a long pipe. They kind of S it around and they come back. And you're sitting there saying, why does that need to be that long, you know? But they go a long way with it so it'll cool off while it's traveling through all that. Okay? Well, sometimes heat exchange takes place where we're not even thinking about it. To prevent the boiling of brake fluid, where brake fluid is piped through high heat areas like the exhaust manifold area of the engine compartment, hydraulic brake lines, have you ever noticed that coming right out of the master cylinder, hydraulic brake lines are coiled? You ever seen that? Have you ever seen them? They're coiled like a spring. And around those brake lines, they'll have a little spring wrapped around the brake line. All right, now all of that stuff is heat-related issues. I mean, I've never heard that taught before, but the only reason, or one of the reasons that they call that, is so that as the brake fluid is traveling through there, you know, if you just got a straight line that's running down there in a hot engine compartment, it's going to be really easy for that fluid to boil. But if it's going around and around and around, it doesn't. Tell you something else. And this is something. How many of you knew this? If you ever see a welder, a guy that's welding, and he's having to hold a rod, and he's heating with a torch. If you take that rod, and you can take a rod this long, and if he's holding it here and heating it with a torch here, it's going to get hot and burn his fingers if he's holding it, you know, without gloves, right? But you can take that rod, and you can bend it that same length, and hold it right there, and heat that son of a gun all the way up to about right there before it ever gets hot down here. In other words, heat does not like to travel around a bend.
Yeah, especially if you heat something at the bottom and you end up with the...
Which one's the wettest?
The whole driver's side is wet like that.
The whole driver's side is wet.
And then one on the passenger side.
One on the passenger side. Okay, that was after running it like 60 seconds?
Yeah.
All right. See if you can drag that scope over there and see if you can figure out a way to connect that scope to the injectors, and I want to see what kind of pulse we're getting. Compare the wet ones to the dry ones. You know what I'm saying? And see what that happens. Now, I will tell you, the little Scotch locks that you see up there in the engine compartment, whenever we first put that thing together, there was no fuel injection whatsoever. It wouldn't inject any fuel. And Christina and Sam put that motor in there, and so we were looking, and there was a ground that wasn't being fed. I mean, there was one of the ground connections that going into the engine controller that wasn't even running grounded, and so we grounded it, and one of them may have grounded an injector line. You know what I'm saying? So I tell you what, do this first. Turn on the key and see if there's any one of those injectors while the key is on. Unplug all the injectors. See if any one of the injectors has got power and ground on all the time. See what I mean? See if they're just always grounded and always powered. If they are, they're just work fuel straight in there, as long as you got pressure. You understand what I'm saying?
So with the key on?
With the key on, with just the key on, you ought not to have power and ground on each injector all the time. You ought to have power, and then you ought to have a pulsing ground when you're spinning it, but there shouldn't be a ground unless you're pulsing it. With the key switched off, you may have a ground, but with it turned on, you shouldn't have. See, that thing's puffing out so much gasoline steam, it has to have some kind of problem like that. That's what I'm trying to get y'all to fix. Okay? Now, pay attention, particularly the ones you're saying that are wet. Okay? All right. Now then, exhaust gas recirculation. You see that? You know the naked pipe I'm always pointing at that carries exhaust gas to the EGR valve? The reason I got a naked pipe there is they want to cool that gas off. As it leaves the exhaust and goes to the EGR valve to go into the mix, they want to cool it off. And so they let it travel a pretty good ways through a naked pipe that's kind of thin-walled. And that gets rid of some of that heat for EGR. Got that? All right, it diverts a lot of that. Okay, so right behind the throttle plate, you know, is where in the heat, if you're wanting to cool off the combustion chamber, bring it below 2,500 degrees during the combustion process, it works better if you've got cool, inert gas to send in there. The EGR's inert gas lowers that temperature, and if you cool it. Now, on the diesels started to have EGR, and they needed to cool that. On the not the 6 liter, well, the one that's got the the 6.4 is common rail fuel injection. It's got
Ford.
two,
The Ford.
Yeah, it's actually got two EGR coolers on it. It's got a horizontal one, it's got a vertical one. When it heads into that first EGR cooler, there's between the exhaust gas going into the first EGR cooler and leaving it to the second one, it's dropping 800 degrees in temperature going through those coolers, basically. All right. So, all right, you got so there's EGR coolers. I need to kind of show you what they look like. There's also an oil cooler on there, and that engine's got they got 7 different heat exchangers on it. Let me show you guys a picture. Watch this. If I can. I'm gonna fire up my overhead there. All right. Now, okay, that's pretty much going to be the end of that right there. You got a turbo actuator, and it's kind of funny. The 6.4 has got 7 heat exchangers and a dedicated coolant system with its own special coolant supply for the fuel system. And so it's got a variable geometry turbocharger on it, and it's over close to all that heat. That variable geometry turbocharger is a smart box, and it's got a CAN bus that controller area network bus that it communicates with the PCM. PCM requests a different turbo angle. If that little thing is too hot, it's going to say, and that's this part that you're seeing right there. If it's too hot, it will tell the PCM that it ain't getting nothing in the way of a turbo angle change until such a time as the PCM has got to turn on that coolant pump. It's got a special coolant system. Now, I'm going to show you something else too. Watch this. See the heat exchangers right there? Those heat exchangers right there are basically the ones, that one right there and that one right there. This is what it looks like when on a cutaway. See where the red would be where the exhaust is flowing through there, and the green is where the coolant is. And just right next to it, there's another heat exchanger. That's the oil cooler. And that oil cooler is basically got pressurized lube oil flowing around it in there. And it's got antifreeze where the green is and all around the outside of it. And so that's some of that. Now see this long tube. Look at the tube, guys. See that tube? That long tube is what's going to cool your EGR. And these two heat exchangers here, where do you think you might find them at? Those right there in the dash on a Ford pickup. And one of them is the evaporator, and the other one's the heater core. That's 2 heat exchangers. You got it? You understand that? All right. I'm going to zoom out. All right. Now then, let me come up again. I'm going to show you another thing. The newer heat exchangers, incidentally, on your 6.4s look like that, and they were really crappy. They had a tendency to fail a lot. And they would get they'd mix the water and the oil. I mean, the water and oil. There's the vertical heat exchanger on the 6.4. There's a temperature sensor measuring that gas going into that thing, and another one measuring it coming out. And that's what a heat exchanger looks like up there on the top. All right. So I just wanted to show you those pictures after I talked about all of that. Look at this. What flows through that? What flows through that line right there?
Steering fluid.
Power steering fluid. See how if you see that, see a lot of people look at stuff, they don't ever think about what they're looking at. If you see that, you're going to actually notice the reason they take that all that way and they go back that way. So they went to a lot of trouble to put them brackets on there. By the time that power steering fluid goes from where it, where it started to where it's going, it's going to be drop some heat. What kind of pressure does a power steering pump put up?
Brake fluid style pressure.
Well, 1,200 pounds. I mean, it's slightly lower, but anyway, all right. Okay, so that pretty well changes that. I mean,